Okay, so after yesterday's video where we learned about the Pythagorean theorem and got to see what it actually means when a squared plus b squared equals c squared, we now get to practice that today. And so after we practice today, you guys are really truly going to be professionals so that tomorrow we can start looking at real life applications, not just these random math triangles, but real life applications of the Pythagorean theorem. To get started, I want you to quickly summarize with your tables anything that you remember from yesterday. So it might be a good idea to have out those notes so that you can review them and start sharing all the things that you learned yesterday from that video. We're going to pause the video while students do this in class. Now please share with me what are some things that you remember from yesterday's video. We'll start with Jacob. Okay, all true, and that's a great application even of what you see here, explaining how we would do problem number 1. However, with that being said, there is a better way to think about the Pythagorean theorem, and here's the reason why. I want you to take a look ahead, all the way ahead to number 11. Do we have a C anymore? Yeah, we have an X. And so I want us to be really clear. Yes, we can say a squared plus b squared equals c squared, but we're not complete if this is all we say. There's a better way that we can phrase this, or a sentence that we can add on to this. What would that be? Emily? Yes, and this is the way I prefer it. Leg squared plus leg squared equals the hypotenuse squared. And here's what I like about this. It's very clear and tells me that the two things that I square and add together have to be the legs. And the thing that it's equal to and then squared is the hypotenuse squared. This is very clear. So this, honestly, is not complete. A squared plus b squared equals c squared is not good enough. You need to say a squared plus b squared equals c squared when a, b are legs and c is hypotenuse. So really, truly, a squared plus b squared, it feels like it's nice and short, but when you have to add all that extra information, it's really not so short anymore, which is why I prefer this one for the clarity. I think this is a little bit more precise. Leg squared plus leg squared equals hypotenuse squared. This one is fine as long as you add that information. A and b are legs, c is the hypotenuse. All right, what else do you remember from yesterday? Callie. Yes, we use it for right triangles only. It only works for right triangles. Great. What else do you remember? There was a lot of talking when I asked you to summarize with your tables, so I should see way more than just Emily's hand. I'll just keep waiting, it's fine. And I'll just keep waiting off the recording so we're not wasting recording time. Thank you. Audrey. Okay, so you're talking about how, even though this looks really intimidating, we see all these squares, really, truly, ultimately, we just need to find the square root in the end, right? Okay, what else? Thank you for these hands. Garrett. Good, and I want you to expand on that. He said, if it's a right triangle, then this always happens. So could we expand on that, but kind of go backwards? Callie? Sorry, Callista. Exactly. So tying that into what Garrett said, if it's a right triangle, this is true. So if we have lengths, we can test to see if it is true, then we know it's a right triangle. That's exactly correct. Zeta. Exactly. Yep. Testing out those side lengths is what did we call it? You remember? Do you remember, Jacob? It's called the converse. It's all your favorite shoes. I don't know why you couldn't remember that name. It's the converse of the Pythagorean theorem. Oh, I guess it's Vans is your favorite shoe, not Converse, huh? What else do you remember, James? Yeah, so just summarizing, squaring the legs, adding it up together is the square of the hypotenuse. Callie. Yes, I was waiting for that to come up. No one said that one yet. The hypotenuse is the longest side. And that is actually going to be really helpful when we are testing triangles, because if I gave you just random lengths like 3, 4, 5, you're like, I don't know which one is the hypotenuse. Well, which one is the longest side? The 5, so we would know what to do with that one. There's something else. At least one more thing that should be mentioned. Cambry. Exactly, and not usually, always. It always is. The hypotenuse, the way we know what the hypotenuse is here's the right angle. It's the one that's opposite that. That makes it the longest side, and it makes it, that is the definition of the hypotenuse, the one that's opposite of that right angle. Kaden. Not quite. It doesn't take 2 legs to make a hypotenuse, but it does take 2 legs to make the right angle. And that's how we define which ones are legs and which ones are hypotenuses, which ones are forming that right angle. Garrett. Okay, I know what you're trying to say, but take a look at number 3. So this is nice because it's like we could draw that on grid paper and it would fit very nicely going up and down and sideways, right? But what about this one? Can you still figure out which one is the hypotenuse? But all of these are kind of diagonally type lines, right? Yeah, so it's the longer one, but also what's the real clue? Opposite side of the right angle, exactly. So instead of talking about how it's always the one that's diagonal, because in this case they're all diagonal, and in this case they're all diagonal, talk about how it's the one that's opposite of that perfect right angle, because that's really what you're noticing, is it's kind of diagonal because it's across from that right angle. Mark. Yes, it only applies to right triangles. If it is not a right triangle, we cannot use the Pythagorean theorem. Jacob, last comment here. Good. So it doesn't work, or it works not just for finding hypotenuse, it works for finding legs too. And we see that in our first 2 examples. So we're going to put this to practice now. I can't remember who it was. Somebody. I really can't remember who it was. Somebody told us, maybe it was you, Jacob, exactly how we're going to use it for this problem. Was that you who said that at the very beginning? So, knowing that the hypotenuse is the one opposite of that right angle, this C right here, that is the hypotenuse. I'm just going to write myself a little note. That's the hypotenuse. That means that these 2, they form that right angle. That means this is a leg, and this is a leg. Or if you wanted to, you can say, hey, this is C, because C is the hypotenuse. You can call this one A, and you can call this one B if you want, or vice versa. It doesn't really matter, because what the Pythagorean theorem says is take the leg and square it. So I'm going to take this leg, 3, and square it. I'm going to take the other leg, 4, and square it. I'm going to add those together. Leg squared plus leg squared is equal to the hypotenuse squared, but the hypotenuse is given a label, and that label is C. So I'm just going to say it's equal to C squared. And now we need to simplify before we solve and watch the work that I show, because you know my expectations are to show work. I'm showing you the work that I need to see on your papers. 3 squared is 9, and 4 squared is 16, and we're going to add those together. And that is equal to C squared. Just doing one step at a time. 9 plus 16. Hope you can do that in your heads, but you do have these marvelous tools called calculators at your fingertips, so you should probably use it if you can't do that in your head. 9 plus 16 is equal to 25. And as was mentioned, now that I'm ready, we can take the square root. To undo a square, we take the square root of each side, and the square root of 25 is equal to, is that the only answer? It could be -5, but can we have a length of -5? No. So although technically there are two solutions, only one of them makes sense because we cannot have a negative length. So C is equal to 5, and we're done with that problem. Are you ready to practice it on your own? Okay. 2, 3, and 4 with your groups. We'll talk about 5 and 6 together, but 2, 3, and 4 with your groups. I'm only given 2 minutes, so I think you need to make really good use of your time. Talk to each other, help each other out. 2 minutes, ready, set, go. Pausing the recording now. Okay, time's up and voices are off. Please take a look at the answers. I have even shown my work. 2, C is equal to 15. That was nice and easy. And then, of course, I throw in the more challenging ones, where 3 is equal to an irrational number, square root of 113. So I keep it as the square root of 113. 4, similar situation. We end up with the square root of 40, but the square root of 40 can be simplified. Because, and here's the work that I did not show, the square root of 40 can be written as the square root of 4 times 10, which can be written as the square root of 4 times the square root of 10. And the square root of 4 is 2. So we have 2 times the square root of 10, or simply 2 square roots of 10. You cannot. You have had lesson on simplifying radicals, so the expectation is that you simplify that radical. On a test, I would give it half credit. Okay, so you guys, as it said in the video, if you know how to simplify radicals, awesome. And my addition to that is if you know how to simplify radicals, which you do, then do it. That is the expectation. Garrett. What are the factors of 40? Okay, so I write it, instead of writing 40, I write 4 times 10. But multiplication underneath a radical can be split up. So it's the square root of 4 times the square root of 10. So I just took this step and I split them into 2 separate radicals. Now I have the square root of 4, which is 2. The square root of 10, which is square root of 10, because it can't be simplified. Does that help, Garrett? Okay. Any other questions? All right, our process doesn't change when all of a sudden we have decimals. Just like it didn't change when we had radicals, it doesn't change when we have decimals. And we have a really fun one here. So we're going to do number 5 together, and then I'm going to let you guys get a head start on number 6. I have a leg, a hypotenuse, so I'm going to set this up as 0.8 squared plus 0.6 squared is equal to C squared. Use your calculators if you're struggling trying to figure out what these decimals are. But 0.8 squared is 0.64. And 0.6 squared is 0.36. Exactly. And 0.64 plus 0.36 ends up equaling 1. So 1 is equal to C squared. Take the square root of each side to isolate that C, and I get the square root of 1, which is 1, and that's C. Talk with your groups. What are you going to do here? Form a plan. 30-second head start. Start working on it. All right. That's your head start. What do you do now? Tell me, what were your thoughts when you got this one started? Callista. Exactly. Yeah, good catch on that. So we're going to take our legs. Our legs are 5. Have to square it. Here's the other leg, square root of 11. So we have to square that. I add those up together and it equals c squared. And when it's time to simplify, you might freak out, but only for a second, because I hope that you recognize, hey, wait a second. A square is what will undo a square root. Yeah, type it into your calculator if you don't believe me. Square root of 11 squared. Good answer. Square root of 11 is, sorry, square root of 11 squared is 11. 5 squared is 25. And guys, if you can't do that in your head, you should be able to. But if you can't, that's okay. That's why we have our calculators, and that's why we should be using them. 25 plus 11 is c squared, and 25 plus 11 simplifies to 36. So 36 is equal to c squared. Now I get to take the square root of each side, and I get 6 is equal to c. So the value of c is 6 units. And now the next set of problems, they've broken it up for you. They're very, very nice. All of these ones we were finding the hypotenuse. But on these ones, all of these ones we're finding the length of the leg. Notice, here's the right angle. Across from that right angle is what we call the hypotenuse. And notice, we have the hypotenuse. It gave us that length. What is it that I'm missing? The leg. Okay? So we need to set this one up by saying, let's see, here's a leg. I don't know what it is, but I know it's going to be a and then squared. Plus this other leg over here. That's going to be 5 squared. Add those up together, and it's going to equal the hypotenuse squared. But I do know the hypotenuse. The hypotenuse was given to me this time, so it's equal to 13 squared. It still is an equation. It still is nice and easy to solve. It's just solved a little bit different way because the variable is in a different position. So a squared is just a squared, but 5 squared can be simplified. That's 25. And it's equal to and balanced with 13 squared, which is 169. We can subtract 25 from each side. That's getting a closer to being by itself, because now instead of a squared and then added 25, now it's just a squared. Thank you. 169 minus 25 is 144. Final solving step. Just have to undo the square by taking the square root of each side. And we get a is equal to the square root of 144. You should recognize that as a perfect square, or type it into your calculator, Kaden. 12. A is equal to 12. Yes, but you don't know what itself is, so you don't know what to divide it by, but you are correct. Because that's what a squared means, is it means a multiplied by itself. So you're dividing it by itself, you just don't know what itself is yet. Okay, you guys get to practice that with 8, 9, and 10. 8, 9, and 10 with your groups. We're going to go just 2 minutes and then we're going to start going over them. 2 minutes, ready, set, go. And I'm pausing the recording. All right, take a look at number 8. There's the answer for number 8. That one was nice and easy. Nice numbers to work with. Yep. Number 9. Where's the hypotenuse? 0.2 is the hypotenuse. It is the one that is opposite of that right angle. So when I set this up, I have 0.12. That's my leg squared. Plus b squared equals the hypotenuse 0.2 squared. Yes, sir? So when I square 0.12, I end up with 0.0144 plus b squared is equal to 0.2 squared is 0.04. I'm going to undo adding the 0.0144 by subtracting 0.0144. Balance it. Do the same thing here. And aren't you glad we get to use calculators? Yeah. Because we get b squared is equal to 0.04 minus 0.0144, 0.256. 0.0256. 0.256. Undo the square by taking the square root, and we have b is equal to 0.16. Okay, and number 10 is a lot like, which one was it over here? Number 6. Yep, this time it's a hypotenuse. So we have a leg squared plus another leg squared, which is equal to the square root of 41, because that's our hypotenuse, which is then squared. 4 squared is 16. 16 plus a squared is equal to the square root of 41, which is then squared. Once again, I'm seeing, hey, this square, that square root, they undo each other. Remember that part where I'm talking? That means you should not be. We subtract 16 from each side. And I have a squared is equal to 25. Take the square root of each side to undo a being squared, and we have a is equal to 5. Okay, notice, and I warned you about this in the beginning, 11, 12, 13, and 14. It's just saying find the value of x. Notice there's no a, b, or c here. Notice the first set of directions said we're finding the hypotenuse. The next set of directions said we're finding the leg, and now we're saying just use it in the appropriate way to find that missing value. So there's no more hints. You need to figure out, is it the hypotenuse that we're looking for? Is it a leg that we're looking for? How do we use it? So I want you to set up number 11 and set up number 14. We are going to go over 12 and 13 together. So do 11 and 14 right now, just focusing on setting up. And after you set up the problem, if you have time to solve, then go ahead and do that. But just set it up right now. You only are given 30 seconds because my focus is setting up the problems. Ready, set, go. Okay, number 11, how should I set up this problem? Michael. Very good. 8 squared plus 15 squared equals x squared, because the x is the hypotenuse, because it is opposite of that right angle. And 14, how would I set up number 14? Garrett. Very good. 2.1 squared plus x squared, because those are the legs, because they're helping to form that right angle. 2.1 squared plus x squared is equal to the hypotenuse, which you said is 2.9 squared. That's how we would set those ones up. Very good. And since you know how to set them up, I'm not going to take the time to solve them because I want to do a little bit more. 12 and 13 are going to take a little bit of thinking, so I want to spend our time there. Since you know how to set these up, you know how to solve them because you just finished solving problems that were like that. As long as you can set it up, you're going to be successful. 12 deserves a little bit of attention because we can see the leg, so that's 10 squared. We can see the other leg, so that's going to be plus x squared. And that's going to be equal to, we can see the hypotenuse, but we need to square that hypotenuse. Notice what that means. We have to square the hypotenuse. We have to square the whole entire hypotenuse. So if you just want to rely on your calculator to do the work for you, that's fine. But you have to tell the calculator exactly what you mean to do. And if you just type in 10 times the square root of 2 and then squared, guess what? It's not going to calculate it correctly. It's only going to square the square root of 2. The parentheses are necessary because we need to square the entire number. And you guys have already done that in your calculators, right? So now compare, and I'm not even going to use the calculator. Watch how I do this. 10 squared, that's 100, plus x squared. This really just means, hey, this is two different numbers that are multiplied together. Square the first number, square the second number. That's really what we're doing. Because again, if you just enter this in your calculator, it's only going to square this. But really, we need to square this part too. And now I'm taking care of that. So I'm just showing you how I can do it without the calculator. But you guys have access to calculators and you can use them. What's 10 squared? 100. What's square root of 2 squared? 2. And what's 100 times 2? Oh, is that what you guys got in your calculators? Okay. We're going to subtract 100 from each side to get that x squared alone. And we have x squared is equal to 100, which we can then take the square root of each side and know that x is equal to 10. So again, it's not a hard problem, but you have to be aware of the relationship between those numbers. Square the whole entire hypotenuse and be careful with how you use your calculator to do that. Okay, number 13, leg squared. So that's going to be x squared plus leg squared. Oh no, it's another variable. Just set up the problem. Don't freak out. Just set up the problem. And then say to yourself, what's x squared plus x squared? 2x squared. This is one of those big blue unit tiles, remember those guys, the big blue x squared tiles, plus another big blue x squared tile. So what do I have? 2 big blue x squared tiles. So we divide each side by 2. And we get x squared is equal to 10. Ooh, good catch, good catch. Thank you for that. No, that was not an intentional mistake. Thank you for catching that. So the 20 is squared. The hypotenuse has to be squared. 20 squared is equal to 400. Now I can divide each side by 2. And we get x squared is equal to 200. We need to take the square root of each side, and I get x is equal to the square root of 200. Fun fact, that's not simplified. Practice with your groups. Practice simplifying it. 30-second head start before I go over it with you. Simplify that square root. Okay, I want to break up 200 into factors, particularly looking for factors that might be perfect squares. What are some numbers that multiply to give me 200? 2 times 100. Again, what's 100 times 2? 200. So do you see how these are the same thing? Now we can break up the multiplication inside of that radical to the square root of 100 times the square root of 2. We're just breaking that up into 2 separate radicals. What's the square root of 100? What's the square root of 100? 10. Square root of 2. Can we do anything with that? Nope. So 10 times the square root of 2, or 10 square roots of 2. And again, I'm not going to take the time to go over 14. The rest is homework. So let's quickly go over the directions for the homework, please. Notice what it says in the first set. This is the first time the triangles are not drawn for you, but our process is still the same. It says 2 side lengths of a right triangle have been given. Solve for the missing side length if A and B are legs and C is hypotenuse. So even though it's not drawn and we can't see the hypotenuse, we know that all of these where the C is, that's the hypotenuse, and all of the A's and B's, those are the legs. Then you have 5 through 12, which are just like what we've done in class. The 13 and 14 are my favorite problems because you're finding mistakes, which, based on Emily finding my mistake in class just barely, I think she's going to be successful with these because, fun fact, that is one of the mistakes that is made. Okay. You guys can find those mistakes. You can skip extra for experts. If you want to do it, you can. I like this problem, but you can skip it. Okay. Now, I'm going to make a deal with you. Here's the deal. Clean up, and then I'll tell you.